In this video, we're going to take a look at how we can go through and use permutations and combinations in applied problems. And before we could start doing that, we have to take a look at one rule of counting methods, and that's going to be called the fundamental counting principle. And it's actually really easy to employ. The fundamental counting principle says that the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So it's actually pretty easy, because all we're going to do is just multiply two numbers together. So two really basic examples. The model of the car that you are thinking of buying is available in 8 different colors and 2 different styles. In how many ways can you order the car? And so there's 8 different colors, 2 different styles. So there would be 16 ways in which you can order the car. Okay. Even if you have more than 2 items that you want to multiply together, so we have an ice cream store that sells 2 drinks, 4 sizes, 5 flavors. And how many ways can the customer order the drink? All right, so we would just take 2 times 4, which is 8, and then we would just multiply that by 5. So 2 times 4 times 5, and that's going to be 40 ways that we can do this. All right, so pretty easy to employ this fundamental counting principle. Now, from there, what we can do is we can kind of use this in conjunction with our combinations and permutations when needed. And just recall that a permutation is used when the elements are distinguishable from one another. So we looked in the previous video and we saw like those yellow dots, and the yellow dots were indistinguishable. But in the key code, when we had a lock, the positions were distinguishable from the numbers from one another. So we want to make sure that we understand that permutations are for distinguishable, and combinations are basically like the yellow dots where it's indistinguishable. So we can't necessarily tell one element apart. And so before we can do any applied problems, we have to make sure whether we're going to use a combination or a permutation. So in these scenarios, we want to determine if the problem involves a permutation or a combination, and we want to explain why. So we have a medical researcher. They need 18 people to test the effectiveness of an experimental drug. And they have 49 people that volunteer. How many ways can we pick the 18 people? And so this would be an example of a combination. And the reason we have a combination is because it doesn't have the names of the people, or it doesn't say something like subject 1, subject 2, subject 3. We just have 49 total people, and we're picking 18 of those people. And it doesn't matter if the person gets picked first or second or third or even 18th. It just matters that that person gets selected. All right. So the reason it's a combination is because the people cannot be distinguished. In this problem. All right. However, in this scenario where we have 7-letter passwords that can be formed from letters S, T, U, W, X, Y, Z, if no repetition of letters is allowed, well, clearly S is different than T, is different than U, is different than W, etc. So this would be a permutation. And the reason it's a permutation is because the letters are distinguishable. All right. Now, if I just said consonants or vowels, well, we know that there's 21 consonants, so it could be any of those 21, or vowels, it could be 5 of those. So if we basically spell these out, it's a permutation, all right? And if we don't spell it out, then it's going to be a combination for us. All right, so now we can go through, since we can distinguish between a combination and a permutation, and we can go ahead and try to apply those. So we have a race in which we have 5 automobiles, and they're entered into the race. There are no ties. How many ways can the first 3 finishers come in? All right. And this is going to be a permutation because it matters first, second, and third place. Okay. So we have 3 finishers and they come in, and we just want to know how that works out. So this is going to be permutation 5, 3. All right. To set this one up. All right. And so to be able to complete this, what we can do is we can just go ahead And we could use a calculator like this. So we have 5 combination 3. We're going to calculate it. All right, and it's permutations. So there are 60 different ways that the first 3 finishers can come in. All right, so 60 ways. All right. Now, and again, this is because we want to make sure that there's specific places. Okay, so how many ways can the first 3 finishers come in? And again, if first place is different than second place is different than third place. If it just said how many ways can the racers finish in the top 3, all right, then it doesn't necessarily matter if they place first, second, or third. But we're specifically saying how many different ways can these 5 people place as first, second, and third. For letter B, we have 9 jokes are listed in a magazine. How many ways can people select their 3 favorite jokes? Now, it doesn't say what their first favorite or second favorite or third favorite. So this is going to be a combination for this one, all right, because we don't rank them, all right? We're just saying pick, we have 9, we're going to pick 3. So this is going to be combination 9, 3. And we're just going to go ahead and we're going to go to our calculator. We have 9, 3, and we're just going to calculate that. We're looking at combinations, and there are 84 possible ways for this to be done. Yeah. And then finally, for this last problem, this is a little bit of a sneaky one. We have 6 male and 8 female sales representatives. And a team of 4 men and 2 women are to be selected to attend a national conference on insurance fraud. All right, so we really have 2 different groups going on here. Now, the first thing we have to do is decide whether it's going to be a combination or a permutation. All right, and if you think about it, it just says 6 males. It doesn't say what their names are. It doesn't say it matters who's picked first or second. And the same thing with the female. So this is an example of a combination. But we have 2 different groups. We have 6 males, we're picking 4. We have 8 females, we're picking 2. All right, so we're basically going to have combination 6, 2 for the males. And for our females, we're going to have combination, or I'm sorry, 6, 4, excuse me. Right, so we have 6 males, we're picking 4 of them. And then we have 8 females, and we're selecting 2 of those. Right? So we have 2 different sets going on here. Right? So we have our male and female sets. And let's just go ahead and compute these by using our calculator. So remember, we have 6, 4. And 6, 4 is 15. So just remember that number. And then we had 8, 2. And that's 28. Okay, so we had 15 and 28. Now, 15 is the ways that the males can be selected. And then 28 is the ways that the females can be selected. And you might remember at the very beginning, didn't we have this fundamental counting principle? The number of ways in which a series of successive things can occur is found by multiplying the 2 number of ways. So the total number of ways that we can pick 4 men and 2 women is going to be 15 times 28. All right, and we'll just use our calculator to be able to do this. All right, so we'll clear this out. We have 15 times 28, and that's going to give us 420 possible total ways. All right, so those are just some of our applications of combinations and permutations. And hopefully this helps you to understand not only how to compute these, but also how to select a combination, or when to select a combination, when to select a permutation.